Okay, so finally, this is the practical portion of the Convolutional Neural Networking video series. If you haven't gone through the theoretical aspect of it, that is, how the intuition part of it, like how the CNN actually works from a theoretical standpoint, from a conceptual standpoint, you may want to stop this and go back to the other videos I have up on my channel, and it will explain to you in detail about how these CNNs work. Because during the code, I'm not going to make too many references to the presentation I did on those. I am going to be making some, but most of it is going to be more practical, hands-on kinds of things. But now, before we start, this is going to be what we're going to do is we're going to do a CNN, a neural network that will take in images of dogs and cats and learn to classify them based on the features and so forth of what dogs and cats look like. Everyone needs to know how to learn dogs and cats. When I first started learning CNNs, this is the first program I learned. So I want maybe other people to learn it too. And the idea is that you get better with it, and then you can apply it to. You can learn how to do it yourself, and then you can apply this once you know the basic protocol down. You can swap out the dog and cat data, and then you can use it maybe if you're a botanist or something, and you work in if you work with plants, you can use this to classify certain plants. If you work with insects, you can do that. If you work with healthcare data, you can classify different tissue types or cell types or maybe tumors and so forth. So that's the idea, is that you learn how to do it, and then you can use this yourself. Before we start here, if you look at here now, you're going to need these libraries here. So if you don't have these installed, this is DNO, Tensorflow, and Keras, if you can't see it. DNO, essentially, that's Python's version of several companies now have their deep learning platforms, how they build their neural networking programs. This is Python. Python's got a lot of things out there. PyTorch is another one. This is DNO. It's one of the first ones that came out, and this has libraries in it that can handle very highly complex mathematical operations and so forth. So we are going to need this. TensorFlow, which is a much newer version of it, really the same type of thing. This is kind of Google's version of their deep learning platform rather. So you're going to need that, and of course Keras as well. Keras acts as like a hypervisor of sorts that operates on top of TensorFlow and DNO. Very good for visual and text data, and has a lot of really cool optimizing functions that we're going to take we're going to utilize. Now, before we begin, if you don't have them, these are the websites right here. Just go to these websites and directly to the install portion of it, and make sure you install the correct one for your operating system. If you have a Mac, which is a very popular one for you in machine learning, make sure you download the right one. This is a Windows computer I'm utilizing here. Also Python, obviously we're using. If you have regular Python, we're at 2.7 or 3.6, which is the latest version. That's the one I'm using here. I'm using Spider. I think Spider is a really great IDE interaction. It's not so GUI. That is, it's not too GUI, but it has a nice scripting page here on the left, and it has the Python terminal here and down on the right. And it has my my training map file explorer here that allows me to set the console working directory as such, and so it just allows me easier access to my data and so forth. So that's why I like using Spider. Of course, you can use whatever you want, whatever you feel comfortable with. I recommend using this. I mean, you can get this from the Anaconda suite. It is a big platform, the Anaconda. So make sure that you have enough room in it, and it does take a long time to download and so forth. Okay, so now what we want to do is that knowing that if you don't have these libraries installed, you may want to stop the video now, go to these websites and install them, and then once you have them installed, come back, and then we can take it from there. Also, very important, you need to go to this website here. This is my GitHub website where I have the final portions of this program and all the information and data that you're going to need. Just copy and paste this right in your browser. It'll take you right there. You have to make sure that you get the training and the test videos for dogs and cats. And that's very important. Training and testing for dogs and cats. You'll see them. And also make sure you get the single prediction test set. is very important. Okay, make sure you get the single prediction. And then once you have that, have everything downloaded, make sure you put it in the right directory where you can get to it and so forth. And so, like I said, if you don't have these, I'm going to stop the video now and go ahead and get all those. If not, we're going to continue on. So now we need to get these libraries and packages put in here, and that's what we're going to do now. So, sorry, that's not. We don't want metrics. We want models. And import sequential, and I'm going to talk a little bit about these and what they do here in a minute. But right now, it's kind of hard for me to kind of talk and type and teach and everything at the same time. So let me just import all of these and we'll talk about them. And okay, so these are all basically all the, there are actually going to be a few more as we go through. I kind of like to install libraries and other import imaging processing libraries as we go along here. But you're going to need the sequential lesson. There's only a couple different ways that is more the best way that you can design a neural network. Essentially, either by sequence of layers or as a graph. You know, there are graph neural networking that neural networks that I do use, but for this one, we're not. This is not going to be. We're not working with any graphs. So if you want to build like a solid model, you have to follow a specific protocol. This sequential library here allows us to do just that. So we're going to build. We're going to start with a variable, and we're going to attach sequential to it, so then we can utilize the functions and methods that are attached to it. Convolutional 2D. If you remember from my theoretical portion of the video, I talk about the convolutional layer and what it does and how it builds these how it uses these feature maps, or rather the feature filters to build feature maps with the filter going through every pixel on the input image and generating a feature map from that. Max pooling. This is where we build nonlinearity and spatial invariance. Very important layer, and it further concentrates the layer as well. The flatten layer. This is the where it just puts in it just kind of flattens, takes all the images from the max pooling layer and just kind of puts in one big long vector or array or tensor, however you want to call it. It's basically like a big array to then feed into the fully connected layer, which is this right here. But then, so that represents essentially all the ANN layers with regular layer neurons. Okay, so now we're going to initialize a CNN. How are we going to do that? Well, let's call it classifier. Okay, and then we're going to attach our sequential library to it. Yeah, and then that will utilize the or actually initialize our CNN. Okay, that's very important to do that. Just to save us a little bit of time, I went ahead and kind of I don't want these videos to be too long for too many stints. So once we start a classifier variable and we utilize it, utilize the sequential function on it, we're going to take the classifier, same thing, right? And we're going to utilize the add method to it, passing the convolutional 2D layer in it. Now, these are how many filters that we want to utilize over each picture, 32. The 3x3 just means the dimensions of each filter. Okay, it can be 3 by 3, it could be 5 by 5. It really depends. These are hyperparameters that you can kind of play around with. The substandard is really 2 by 2 or 3 by 3. We're going to use 3 by 3. To get a little bit more accuracy or even less accuracy, you can go back and fiddle with these later. It's really not that important. The input shape, many images, the input images, we have to kind of make a kind of a standard set of images that input images come in that they adhere to. So we're gonna, this is what the 64 by 64 is. So every image shape, it's gonna cut it down and crop it into a 64 by 64 image, and that's going to be very important. Again, you can play around with this. It can be 32 by 32. It really all depends. Activation, well, this is very important. Make sure that we're using the rectified linear unit. Again, I did talk about what the ReLU function does. It's an activation function that is good to increase non-linearity, as many pictures are, photographs are. So make sure that we use that. Since we're going to use 2 layers, we use 1 layer and then we used another layer. This is the same thing as this one up here. I just didn't put the input image argument in. You don't need to. You just need to do it once, and then really that's it. Okay. So make sure you put these 2 in. You can actually use 1 or 3. You can actually use as many layers as you want. Again, this is your project. This is your program. You can kind of fool around with this as much as you want. Really based on the accuracy ratings that we get when we run the whole thing. But that's not going to happen until later. But just to let you know. Okay, that's it. So in the next part, we're going to go through the max pooling and flattening layer, and we're going to talk more about that. Okay, but until then. Take care, and I'll see you then. Okay, bye.